Hello, everyone. Welcome back. Today, we're going to get started on some of the basic principles of object-oriented design, starting with what are classes and subclasses. So we will learn about the most core principle of object-oriented design, which is classes and inheritance. So what are classes? A class is basically something that describes a group of objects, and this could be anything that you want to implement in your system. So for example, if you want to keep track of employees, you could have a class called employee. An employee could have attributes or properties like a name, number, an employee number, employee ID, a department, and you have methods or operations on these employees, like you hire an employee, you fire an employee, you assign a project to an employee, and things like that. So those would be your operations. So what are the different aspects of a class? Well, class will need to have a name that is of course, required. Ideally, they should have some attributes that describe some of the properties of the classes. Now, not all classes will need attributes, but most of our classes that we would be using will have some sort of properties that we can deal with. Remember, these are properties that we are storing information about these classes that we will need to work with in our operations. So that brings us to the third component of a class, which is the operations. So you have everything that you can do within that class. So remember that operations need to have something to do with the class at the core, right? You could have other classes or other things involved in the operation, but it needs to have something to do with that class itself. So for example, hiring, firing are really core to that employee. An employee gets hired, an employee gets fired. Yes, they are related to the organization that is hiring or the organization that's firing the employee, but at the core, the operation is on the employee himself or herself. This third one, assign a project. Again, the core aspect of this operation is the employee. Now you would assign a project, so there's a project involved that you will use, but the most important part is the employee. That's important to remember, and that is something that we are going to see going forward. So what can we do with classes? Well, we create instances of the classes. What is nice about a class is it is generic. So for example, employee is a generic class. You could basically use any employee and use our employee class to represent that employee. So for example, here we have an instance or an object of a class called Fred Blogs, and that's the instance. So when we create a class, we are not thinking about a specific employee. We're thinking about attributes and operations that any employee could have in common. When you are actually in an application, what you need to do is you have to create an instance of that class, and then you can run your operation on them. And when you create an instance, you have to provide the values for all of the attributes that that class needs. So technically anything can be an object. You could have, just think about what you want to use in your class and see if there are multiples of those that you can incorporate, make that into a class. Think about properties that it could have and implement those in the class. Now, there are certain things that should not be classes. So for example, something that is inherently simple, like a color. Well, you could create a class called color if you are dealing with different intrinsic elements of a class. But if all you want to do is like a description of a color, like blue or a size or something like that, you don't want to create a class for that. So obviously, remember that anytime you create a class, you're introducing a little bit of complexity in your application. So if it does not need a class, don't create it for no reason. Another thing that should not be a class is something that is just an operation, right? Maybe you should think about that should belong as a method on some other class where it belongs to. So don't just create a class that has one operation in it, or instead think about where else could that operation belong to. And we will see how those come into play in future videos. So how do we find these classes? Typically, if you are looking at different types of applications, if you have data, that data will give you what kind of classes you need. In our case, we are talking about the Raspberry Pi Pico and classes around it. That makes it a little easier because a lot of the things that we are going to be working with are physical objects. So if there are multiple of those physical objects we want to use, or even, we want to reuse that object in other places, it might be a good idea to create a class with it. So for example, if I just switch to the Pico here, this is something that we built last time, and you can immediately see lots of different classes here. For example, these lights are classes, so we can create a class called light. The display is a class. We can create a class called display because display has some properties, number of lines, number of columns, methods like, show some text or show some numbers. So those would be methods. There are other things like buttons. Those could be classes. We can do things with them. Here is a buzzer. We can make that into a class. We can have an operation like play music and things like that. So those things become easier, or at least physical objects, creating classes for them become easier. But then you are going to be creating more conceptual objects, like last time we created a traffic light object, which really is a combination of three of these objects that get together to actually implement this application. Behavior is a little harder because you don't actually, see it as a property. You have to think about what operation these things do. So for example, in case of a light, yeah, you're turning it on and off. You could also think of other things like flipping the light, so you don't care what it is, whatever state it is in, you're just changing it to a different state. Things like that. So behavior takes a little bit more used to, but then, at least to start with, since we are dealing with physical objects, you will see that is a lot clearer initially. And then when we put together these composite of the objects, we will find operations and behavior that we want to implement. So before we get into actually doing an implementation today, I want to do one more concept in object-oriented design, which is subclasses and generalization. This is what makes classes so cool, that you can create a class, and then let's say your application changes. Let's say you have an LED and you built a class that beautifully works with the LED, but now all of a sudden somebody gave you a different kind of light that requires different voltages, different currents, and things like that. So what you were doing with the LED doesn't work very well with it, but basic concepts still remain the same. Well, what you do then is you take your class that you have already built and you create a subclass of it. Things that you can already use directly from the class you already had, that subclass will automatically inherit those, right? Behaviors are automatically inherited, and we will see later on that Python is a little quirky about attributes. Attributes, in order to inherit them, you have to do a little extra work. But at least technically, in an object-oriented design, when you create a subclass, anything that the superclass, that the one that you're inheriting from, has, you already have access to that. Now, if you want to change something or do something different, what you do is you overwrite those things. So for example, in this case, we are talking an example of an employee. Employee could have a year-to-date earnings, and that's common to all employees. And then an employee could have some sort of a method that computes how much they get paid. Now, a full-time employee will get paid by a weekly rate or a monthly rate and things like that. So how you compute the pay is basically how many weeks they have worked times their weekly rate. Whereas a part-time employee does not have a weekly rate, they have an hourly rate. So you have to really keep track of how many hours they have worked and things like that. And that's what you use for compute pay. So what you would do is you would create subclasses of your employee class, and you would override the compute pay method in your individual subclasses so that when you actually call the method, the system will decide which one to call because it knows what kind of employee you assign to that variable. And we're going to see that in an example real quick. So the generalization is super useful because you can kind of treat it as a Lego brick. So let's say you build this beautiful model of a Lego something, and then all of a sudden you need to add more stuff to it. You don't have to start from scratch. You can take what you have already built and you can basically add more things to it. Now, the comparison sort of breaks a little bit because in Legos, you can't really override things. You basically extend. But in object-oriented design, you can actually override. You can actually say that, hey, I do not like this characteristic of the class. I want to change it. So in the subclass, you completely change the behavior. So let's take a look at what we did last time and see it in an object-oriented design. Last time we created a traffic light which controls three lights, right? And if you look at the source code that we created last time, we had a traffic light which had three light properties, red, yellow, and green. They were all lights, and we created instances of lights for these guys. And then we created a constructor. We created an operation called go, caution, stop, and operate. Well, in order to go, we remember that we had to turn on the green light and turn the red and yellow lights off, right? Um, Caution was turning on yellow and the other ones off. Well, today what we're going to do is, let's say we have changed um, our operation. Instead of uh, light with a traffic light with these three lights, as you see in the um, um, running on the Pico, I want to change it to use an RGB light, right? I want to use this guy. Well, this guy does not have three separate lights. Technically, it does have three separate internal nodes, but you cannot separate them out. And also, they're not red, yellow, and green. They are red, green, and blue, right? It's kind of like a pixel, which has a red, green, and blue component. But this thing can still show yellow. You just have to show a different color on it. But let's say your objective has changed, and now instead of using this three different lights for your traffic light, you only want to use one light to show all three colors, red, yellow, and green. Okay. Now, if you didn't have an object-oriented design, you probably would have had to redo most of your coding. In object-oriented design, all you have to do, though, is create a subclass. So I already have put all my work on traffic light, and now I can't use this very well. So let's just create a subclass. We're going to create a subclass called pixel traffic light, and this is going to use a pixel instead of three separate lights. So if we are using this as a traffic light, this thing has a pixel. And again, it would initialize kind of the same way. But notice that previously, when we were saying go, we were turning one light and turning off the other ones, right? Here, go is going to show a color on the pixel, right? And we can go deeper into Pixel later on as we talk about color screens and things like that. But right now, showing a color is not just a matter of turning it something on and something else off. It's a matter of displaying a color on a pixel. Internally, you display colors in an RGB LED by changing the brightness of the different color pins on there. We're not going to go into the details of it, but we're going to say that there is already a class called Pixel. And that's, again, another cool feature of object-oriented design, that if somebody has created a class for you, and which you will see that we have been using classes from a library of object-oriented classes that we're going to be using for these series of videos. So Pixel is one of them. And that has a method called setColor. And you can give it an RGB tuple, and it shows you that color. So all we have to do is we're going to override the go, caution, and stop so that it's not doing what the traffic light was doing, but the operate could stay the same. We can just inherit the operate method. We do not need to rewrite that. So let's take a look at how that is going to work in our walkway design. So this is going to be kind of a fast example, but you will see how that works. So the first thing we're going to do is we're going to upload the class that implements the pixel class, and that is the composite lights.py class. And this is, again, all of these classes that I'm going to be using is in the PicoLibrary GitHub repository, and I'll put a link to that in the description of the video. But things like lights, log, composite lights, they are all classes from the PicoLibrary. This is the one that we wrote last time. So here is our traffic light class, and it's got an init, and it's got a stop, caution, go, and operate. So what we're going to do is we're going to create a subclass of the traffic light class. So we will say class, let's call it pixel traffic light. And it would have the same structure, but the thing that's different is going to be, we're actually going to make this a subclass of the traffic light class. So notice that when we created the traffic light class, we just said class traffic light. Now we're going to say class pixel traffic light, which is the subclass, and we'll put the superclass in parentheses. Same thing with the init. We will say def init. And we can take pins. So instead of a red, yellow, green pin, we need to provide the RGB pins. So we could say R pin, G pin, B pin. So those are the red, green, blue pins. And in here, instead of creating these three lights before, we are going to create an instance of the pixel class. So we can quickly take a look at the pixel class in composite lights. And if you look at the pixel class, it has an R pin, G pin, B pin, and then it also, this class also lets you use either a common cathode or a common anode. We're not going to go into the details of that, but by default, I believe these guys are, oh, see, this one was a common anode, so we will turn this into a common cathode. Those are easier to work with. So, so that's part of the hardware, whether you send positive or send negative to the pins, that's how that makes a difference. So essentially it takes those three pins, and common cathode by default is true. So I set it to common cathode. We'll just use the default there. So what we will do is we'll go back here, pixel, and we will send the R pin, G pin, and B pin in here. And just like before, we will say self.stop. We also know that we can't use these stop, caution, and go methods anymore because they individually worked on these things. So we don't want to do that. We will say def stop. And that is going to show when the traffic light is stopped, it's going to show a red color. First, let's just define the red colors. We're going to kind of manually define them today. In the future, we will use a separate color class. But since this is a simple example, we will just say red equals RGB tuple. So it's 255 for the red component and green and blue are 0. Then yellow, well, let's do the green. That's easy, right? RGB, red is 0, green is full intensity, blue is 0. Now yellow needs two things. Red and green are going to be full intensity, but blue will be 0. So we'll say 255, 255, and 0. So those are our colors. So now all we have to do is self.pixel. That's the instance of the pixel class we already had. And we're going to call the operation as called set color. And for stop, we will just say red. And let's just, we do not like copying and pasting, but since we're in a time crunch for a video, we're just going to paste this a couple times. So this is going to be caution, and this is go. So caution is going to show yellow, and go is going to show green. So let's just quickly wire this up to see how this works. So common is usually going to go to ground. So we will put a connect ground pin there. The red pin, we're going to connect to pin 3. The green pin will connect to pin 4. And actually, let's do it the proper way. On the simulator, you can connect your RGB pins directly, but in the real hardware, you probably do not want to send full 3.3 volts to the LED, right? So let's do it properly. We are actually going to need this resistor. So I'm going to make a copy of that and paste 3 times. Now in Walkway, one of the things you could do is you can click on any item and then hit the R button, and that turns it, makes it a little vertical. So let's put this somewhere so I can still fit this in. That's how we have connected. So 3, 4, and 5. Okay. So now let's go to our main program and notice that before we were creating traffic light, right? But instead of traffic light, now we will say pixel traffic light. And if I run this, look at that. It's green, then it's going to turn to yellow, and then it turns to red. So instead of our 3-letter traffic lights, now we have created a nice little 1 light traffic light, but it still has the same functionality, just using a different hardware. And we didn't have to recreate operate. Operate is still using the same operate method that it was using before. Notice that my pixel traffic light does not have operate, but in main, I created an instance of pixel traffic light and I called the operate on it, and it still works the same, although it does not have an operate. Where did it get it from? Well, it just inherited it from its superclass, and it only works because we have defined it pixel traffic light as a subclass of traffic light. So that's basically how you make a subclass, and that's the utility of a subclass. Of course, we can put this on the Pico. I'm gonna pull my Honey up. The video does not complete unless we actually make our Pico work. So here is Tawny. And so here was our old main.py and so we're going to turn this into pixel traffic light. And this is 3, 4, and 5. Of course, our traffic light now will need to have the new definition. So we'll go back to here, we'll copy this, and we will paste this into Tawny, save, copy both of them to our Pico. Now we're going to run this one. Now watch what happens. This was, of course, this is stopped now because I stopped it. But now I'm going to run this new main program. And now you will see, oh, we have an error. No module name composite light, right? So we need that module in there in order for it to work. So, okay, so we're going to go ahead and copy that over, that composite lights.py, and we will upload that to slash. And now when I run this, as you can see, instead of the red, green, yellow, red showing on these 3, we're seeing it on the pixel. There it is, yellow and red. That green is still there because we never turned it off. This is a different application. And when I stopped it, the green was still on. So if I just restart this Pico, now we have disconnected it. Now we run it directly from the battery and watch what happens. It runs only on the pixel without turning on these other lights. So there you go. We just subclassed our traffic light and turned it into a pixel traffic light. Hope this was useful, and we'll see you in the next video.